Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 4 of DevSecOps Zero to Hero series, and in this episode, we will focus on securing containers. In the last 3 episodes, we learned introduction to DevSecOps, then we learned securing Git. In the previous episode, we learned security best practices for Terraform. In the same way, in today's video, we will learn security best practices for containers. We will focus on 5 different topics in today's video, starting with what are the security challenges of running a container with root user, which a lot of people do, especially the beginners, and how to run the containers as non-root users. What changes do you need to make in the Docker file? Then we will learn what are advantages with multi-stage Docker builds from security point of view. Then we will learn one of the most important security aspects for containers, that is distroless images. What are distroless images and how can they add security to your containers? Then we will learn about simple but very efficient thing, that is .docker ignore. How can you introduce this to your project? And finally, we will learn about hardening container runtime. So we will learn how can you add few parameters to your Docker run command that can harden the security of your container. So these are 5 different topics that we will focus in today's video. We will go step by step. We will learn each topic using a demo. And you don't have to worry. Everything is documented within this GitHub repository. So if you go to Day-4 folder, I'll share the repository link in the description. Just head to the Day-4 folder, container security. You will find the README file. And within the README file, you have all the steps, commands that I'm going to use, even configuration files. So after watching the video, spend 15 to 20 minutes more and implement the demos at your end. And to add to it, we will learn using a sample application in today's video. We will create a Docker file for a sample application, which is a Node.js application, and we will learn how to improve the Docker file to accommodate the best practices. Now, what is this demo application or the sample application? Because our focus is not about application, I've taken a very simple Hello World Node.js application. So this application runs on port 3000, and when you run the application, it will just return hello from the container. Then it also returns the user ID with which container is running. Let's say you run the container with root user, it returns the user ID as 0. If you run the container with any other user, it would return the user ID accordingly. And finally, it also prints the host name. So these are 3 things that the application returns, Node.js application returns, when it is run within a container or even outside. And how to run the application? Again, this is something that you need to know before you start writing the Docker file. So to run this Node.js sample application, first you will build the application using npm install, and then you will run the application using npm start. That's all. This is good enough information for you to get started with the Docker file. So all the files are here. app.js is the source code for the Node.js application. Package.json is the dependency file. So here we have Express as one of the dependencies for the application. Perfect. Now let's get started. So let's see how a junior DevOps engineer who does not care a lot about security, but cares about completing the task. What is the task? To containerize this Node.js application. How would that junior DevOps engineer write Docker file for this use case. Of course, the very first thing that this junior DevOps engineer does, take the terminal, right? So I have a terminal, and then the junior engineer clones the project, because to do anything, first the engineer needs the source code. So this person would clone the repository. In our case, the source code is in the same repository, DevSecOps 0 to hero. So let's get the GitHub URL and run git clone inside a directory. I'll go with Docker directory on my local machine. Okay, so I already have the project here. Let me just remove the project so that we can start from the basics. Git clone followed by the URL. Perfect. Day-4 folder, DevSecOps 0 to hero, Day-4. The junior engineer starts writing the Docker file, or let's say DevOps engineer, not caring a lot about security, Vim Docker file. Perfect. Now, because this is a Node.js application, right? So what we are dealing with is a Node.js application. So what should be the base image? Base image in this case should be the node base image, so that you don't have to worry about the Node.js installation. Let's say you go with Ubuntu base image. In that case, you have to use the run command to update the apt repositories, and then you have to install Ubuntu on the base image. Instead, you can directly go with node 25, because 25 is the latest version. If you are not sure what is the latest version of the image, just head to the Docker hub and you will find the latest tag version. Perfect. Then the junior engineer would create the work directory, let's say /app, so that all the commands would run within the work directory. Then the junior engineer would copy the source code, in this case app.js and package.json. Then the junior engineer, as per the instructions here, the first command is npm install and then npm start. This is for build and this is for running the application. Okay, npm install, expose the port 3000, and finally within the cmd or entry point, the junior engineer would add the fields npm followed by start. Now this can be within the entry point as well. Perfect. So now the junior engineer verifies the Docker file by running the Docker build. Right? Let's see one more time. Cat Docker file. Okay, the file looks good. How do you run the Docker build? Very simple. Docker build. Basically, we are creating Docker image from the Docker file. Docker build. Let's provide it with a tag. Let's call it as insecure image, followed by dot the location of the Docker file. Okay, so I don't have Docker running. I think I stopped Docker sometime back. Let me just restart Docker. I'm using Docker desktop, so I just started the Docker process. Let me verify again. There you go. Now the build is running and we have the Docker image created. Cool. So now the junior engineer verifies by running the container to see if the Node.js application is running. How would the junior engineer do? Docker, or let me clear the screen. Docker run -it interactive terminal, or without an interactive terminal, just -p port 3000 bind to the local host followed by insecure image. Okay, so the container is running. As final step, junior engineer would take a duplicate tab and verify by just running curl localhost colon 3000. There you go. Hello from container, hostname, UID. Now, the task is complete, right? So the junior engineer or someone who is assigned with this task and does not care about security, they would say, there you go. My task is complete. I created the Docker file. The Docker image is also created, and I verified by running the container that Node.js application is running successfully within the container. Now, even you might say, Abhishek, the task is achieved. What to do more? Let me tell you, there are security challenges with the Docker file that is created and also issues with the container that is running. The first and the foremost issue, if you look at the UID, the user ID is 0. That means this container is running, but it is running as a root user. I can also show you. Now I'll just stop the container. This time I will run the container in the interactive mode. So if I just do -it followed by sh to take the shell on the terminal, or bash as well. Let me just do sh. And here if I run id, you will see the id is the root user. That means this container is running as a root user. What are the security challenges here? What are the security issues? Very simple. Take example of your laptop. Would you give access to your laptop to someone as an administrator? Typically no, because they can create new files, they can download anything on your laptop, or even if they are bad actors, they can run hundreds of processes on your laptop and technically make your laptop unusable. In the same way, now if a bad actor gets access to your container, the bad actor can create multiple volumes within the container, just like that, to make your container look heavy, or maybe to indirectly, if the volumes are running, this is stored on the local machine where your container is running by default. So this way they can even perform spam attack on your host machine. Same way, just like volumes, they can also run n number of processes. Imagine a bad actor running 200 processes within the container just to make your host. The container is running on a virtual machine or a host. If 200 processes are running within a container, they utilize the resources on the host. Technically, your host becomes inaccessible, or other containers that are running on the host do not get enough resources. So they can perform DDoS attack. Or most importantly, what a good bad actor can do, or what an efficient bad actor can do, is because the container is running as a root user, they can even get access to the host. Why? Because if you are using Docker as runtime through the container, they can access the Docker daemon because they are a root user, and from the Docker daemon, because Docker daemon runs as a root user, they can get access to the host as well. Understand this carefully. You are only thinking about container, right? You are thinking that my container is running as a root user. What's problem? But if your container is running as a root user, because the container is running on a host, right? Let's say the host is a virtual machine, and the container is running using Docker runtime, and Docker runtime always runs as a root user. Docker daemon runs as a root user. Now this bad actor can get access to the Docker runtime, and from the Docker runtime, they can get access to the host machine. Now, if they get access to the host machine, they are already within your network. They have complete access to your infrastructure as well, if you don't have proper virtual private cloud. Now, this is something I'm not making it up. You can find a lot of similar stories on the internet. Because of using a root user within the container, lot of company's infrastructure was compromised. You can eliminate that. You know, if you are a good DevOps engineer, if you want to follow security best practices, just using two more steps in the Docker file, you can run your Docker container as non-root user. Let me show you how you can do it. Two basic steps. Now, use the same Docker file. There is no problem. Vim Docker file. Now, I will update this Docker file. One, I will create a user within the Docker file. Just before you perform any instructions within the Docker file, even before copy, just create a user. So here, group add -r user. So basically, I'm creating a group and basically I'm adding a user to the group. I'm calling it as app user. If you want, you can call it as Abhishek user, you can call it as XYZ user, or you can call it as a developer, whatever you feel like. And just switch the user. How can you switch the user? Use the user keyword within the Docker file and the name of the user that you created. That's all. Till here, commands are executed as the root user. And when you use this user keyword, from this point, the user is switched to the regular user. In our case, app user. So now, whenever someone logs into the container, they will log in as an app user. This app user does not have elevated privileges like your root user. So even if they want to perform something, they will fail to do it. Let me show you. Now we will create another Docker image. Okay. This time, Docker build -t. Let's provide the tag name. Let me just call it as rootless image or non-root image dot. Let's see what happens now. Okay, the image will be built fast because of the Docker cache. Docker already has the cache. There you go. Now, Docker run. Let me run it as an interactive terminal so that I can show you. Docker run -it non-root image sh. Okay, so I'm taking shell within the container one more time. Enter. Now let's see ID. I'll run the ID command again. Non-root user. So you can see this time user is the app user. Abhishek, can you show by running some command so that we know it does not have elevated privileges? Let's see. We will run apt install x, a random package. What does it say? Permission denied. We can also try with sudo. Let's do sudo apt install x. What does it say? Sudo does not exist. That means using this user, you cannot perform sudo. So this way, now the end user, whoever has access to this container or even a bad actor, through some way, if they get access to the container, still it's not a big problem for you because they can only access the container as a non-root user. But Abhishek, still the application runs within this container? Yeah, we did not make any significant changes. If we just do docker run -p 3000 :3000 followed by insecure image, non-root image, we should see the container running. It says port 3000 is already in use. Let's change this to 3001. Okay, on the other terminal, this time curl 3001. There you go. Hello from the container, host name, user ID is 999. So the application is running and we also ensured application is secured. All with just 2 lines more to the Docker file. What we added? We added the run command where we created a user and a group, and then we switched to the user before running the CMD. Now the junior DevOps engineer or someone without a security approach, they might think that the task is complete. Okay, now I'm running the container as a non-root user. My task is complete. Let me tell you, the task is still not complete because if you do Docker images, you will notice something very, very important. What did we create? We created non-root image user. This is the final one that we created. The content size, that is the image size, is 401 MB. Just for a simple Hello World application, your container image size cannot be, or your Docker image size, let me put it that way, cannot be 401 MB. It's too much for your image. All that you have is this simple thing, 20 lines of code. But Abhishek, how does that create security issue? We are talking about DevSecOps. We are talking about security issue. How the container image size impacts my security? It does. Because when your image size is more, understand this carefully. If your image size is more, that means you have more packages within the container, right? It can be two things. It can be system packages, that is your base image packages, the one that comes with Node 25. This is the base image that we used. Or it can be because of your application packages. So we ran npm install, right? When we run npm install to build the Node.js application, Node.js or npm can download packages from the internet, and even after the application is built, some of these packages can stay within your container image. Now, this is a problem because you don't need these packages at the runtime. See, there are two stages for every application. One is build stage, one is the execution or the run stage. You need a lot of packages during the build stage because you want to download the packages from the internet, right? To build the application, to compile the application. But you don't need all of those packages during the runtime. During the runtime, you have, if it's a Java application, a jar file, war file, or you have basically a binary. And you just need this binary and runtime environment to run the binary. That's it. Now, if you keep these packages that you downloaded still in the container image, you are not checking on the timely basis if these images are vulnerable. Today, those packages, today those packages are not vulnerable, let's say. If you take example of ABC package, okay? ABC package, you must have downloaded 1.0.0 for building your application. Today, this package version is fine, but maybe 2 months down the line, there is a critical security issue with this version. Now, ideally, you should upgrade this to 1.0.1, but why would you log into the container? Why would you bother about checking the version? A lot of people would ignore that. So your container, it is running in production and it is still running with 1.0.0. Imagine a bad actor get access to your container. They might get access as a non-root user, but still, because there is a vulnerable version, the bad actor can attack through this vulnerable package version. So this package can be a threat for your organization. How can you avoid this? Very, very simple. Just break your Docker file. Okay. Just break your Docker file into two parts. This is what we call as multi-stage build. The first stage is the build stage. Second stage is the run stage. If required, when you are dealing with, a two-tier application or something like that, you can even add more stages. But typically, you can add a build stage. You can add a run stage. In the build stage, for our use case, focus on npm install. In the run stage, focus on npm start. And from the build stage, just take the binary that you created to the run stage. And finally, the image that you created will only have the run stage artifacts. Okay, this is the advantage that Docker brings onto the table. In the Docker file, you can create n number of stages, but what Docker will consider only the last stage. I mean, the image that you have will be only created from the last stage. So what you will do as a DevSecOps engineer, you will use the build stage. In the build stage, you can download any number of packages. You can get them from the internet. You can do anything. Build the binary. And to the run stage, just copy the binary and have the container runtime. In our case, what is the container runtime? Node is the container runtime. So in the run stage, you can just have node container runtime and binary that you created in the build stage. That's it. Create a CMD and you can have your runtime environment ready. And when you do this, your container image size will significantly go down. And if the container image size significantly goes down, that itself means there are less number of packages within the container. When less number of packages, less impact radius. Let's see this in live. Okay, I'll break our container image into two stages. This time, I will create a new Docker file, or let's delete the existing Docker file, rm, or maybe let's create a new one. Okay, I'll create a folder, mkdir, multistage, cd multistage, vim, Docker file. Okay, so we need two stages as we discussed. The first stage, we will keep it the same, node 25, and I will provide an alias to this stage. I'll just call it as builder. Let's choose work directory. Build stage will look more or less the same. Work directory. This time I'll just call it as /build. Then we will copy the package.json first. Abhishek, why do you only copy package.json? I've seen this multiple times. You use the two different copy commands. The first time you copy the dependency file, you run the dependency command, and then you copy the complete source code. I've seen this a lot of times in your playlist as well. The reason is simple. Why I typically do this is because Docker builds layer by layer. That means this will be a different layer and this will be a different layer. So that let's say your source code is changed. Docker does not have to run the dependencies again and again. Typically, a lot of times, dependencies is the one that takes a lot of time for building. So if you want to reduce your Docker build execution time, make sure you break your dependencies in a different copy command and you take your rest of the source code in a different copy command. Perfect. So as per the concept that we learned, in the build stage, we are using npm install. Now we will create a runtime Docker stage. Here, instead of taking node 25, I will take node 25 slim. What is the advantage here? Node 25 slim is a lightweight Node.js image, which will not have a lot of things that your regular Node image has. Are you fine with it? Yes. Why? Because we can go with node 25 slim or lightweight image, because in this stage we are only executing the Node.js application, or we are only running the Node.js application. Here we are not building the application, so we don't need a lot of packages that are available in the node 25. Perfect. And these images are specially created for multi-stage Docker builds. So if you look at Docker Hub, you will find Python slim image, you will find Node.js slim image, which you can use in the runtime environment or runtime Docker build. Perfect. Now, again, we will choose the work directory. This time we can choose /app, copy As I told you, we will copy the binary or the artifacts that are created in the build stage. Now, what are the artifacts that are created? In Node.js, artifacts that you create are basically the node modules. Apart from that, we will also copy the app.js, okay, which is our application source code. That's it. We will expose 3000 and finally cmd followed by node app.js. So we will not run node start. We can just run node app.js because we already have the node modules that are the modules required to run this application.js file. Now you will notice when you build this Docker image, the size of the image will be significantly less. Let's see Docker build -t. Now let's call this as multi-stage image followed by dot. Okay. So it says fail to build the computer cache, fail to complete checksum at reference. Copy package.json to dot. Okay. It's a very simple mistake. Basically, we have created a new directory. Like if you look at our pwd, I have created a new directory called multistage, and here I don't have app.js or I don't have package.json, right? So what we need to do, either we will move this Docker file a folder back, or we need to copy app.js and package.json to this folder, right? Only then your copy command works. Let's do that. Copy dot app.js to this folder. Similarly, copy dot package.json to this folder. Now let's see. Okay, we will run the Docker file again. This time it should work. It's working fine, I guess. There you go. So we have the Docker image running. Let's see the size of this Docker image. Docker images. Okay. Multi-stage image 79.5 MB. That is straight from 400 MB to 79.5 MB. And most importantly, now the application that we're dealing with is a very small application. It just has app.js and package.json. Imagine when you are working with an e-commerce application or a real-time application, it has hundreds of files. Then it will be more advantage for you in terms of the container image size. So we saw the advantage from 400 MB image size shrank down to 80 MB. So it is typically 20% of your entire size. 400 MB to 80 MB, 80% reduction. Cool. Now, if you think your job is done, let me tell you, your job is still not done. Why? Even now, you have a chance to reduce your container image size, and you have an opportunity to use even less packages on your container image. But Abhishek, what packages? Let me tell you, if you exec to this container image, once again, so if you run docker run followed by multi-stage image sh, okay, let me exec to it by taking -it. You will notice here there are a lot of system packages. One example, apt. Why do you need apt in the container image? Okay, if you want to run this container in the production, what is the advantage of apt? Why do you need it? You might say, Abhishek, nobody can install packages using apt. Then what is the purpose? You can just remove it. Similarly, there will be hundreds of packages on this Node 25 slim image. Okay, it's a slim image. It can help you, but still you have hundreds of packages in it which are not needed. A good hacker will still find the ways. If they have apt, they will find the ways, some or the other way, hook or crook, to install something on your container and hack your container. Not only apt, I'm talking about /etc folder. There will be hundreds of packages in it. What is the purpose of it? This is where distroless images can help you. Distroless images are images which not only help you with reducing your image size from app packages point of view, but they can also help you reduce system related binaries within the container. How do you do that? You don't have to change a lot. You can just use the same container image that you used. Only change that you have to make within the Docker file. Let me show you by updating it. Right? From multi-stage to distroless is very small change. All that you have to do within your runtime, right? Here from Node 25 Slim, go with a distroless image like this. GCR, Google Container Registry, it has distroless images, Node.js 20, Debian 12. But Abhishek, why are you not using Node 25? This is one drawback. When you are going with distroless images, you have to depend on systems like GCR, where Google Cloud or open source contributors, where they are creating distroless images for you, and they might not keep it up to date with latest Node.js version. So right now we don't have Node 25. Node 20 is up to date. So we can use Node.js 20. So you can keep it the same way. In fact, you can remove Node here and just run app.js, because the entry point for this distroless image is Node. So even if you have app.js, it will run node app.js. Let's see. I will save this Docker file. This time let me do docker build -t followed by, let me call this as distroless or distroless image demo followed by dot. Okay. Now let's see Docker images. Okay. What is the image size now? From 80 MB, it went down to 52 MB. Further reduction in the size. Typically looks like 85% reduction in the container image size. Great. Now let me show you the application works absolutely fine. You might think the container image size is less, so your application might not run. It actually runs. Docker run followed by -p. This time let me use 3002, 3000 followed by distroless image demo. Okay, let's verify. I'll just do localhost 3002. There you go. Now the application is still running on your machine. Cool. What else? Abhishek, now the application is running. We verified application is running within the distroless image as well. This is absolutely fine. Your Docker file is now secure. You can even ship this Docker image to production, but there are few simple best practices that you can follow, which can add to what we created till now. A simple best practice that DevSecOps engineers follow is to create a .docker ignore file. So just like how we create .git ignore file, good DevSecOps engineers create .docker ignore file within the repository, right? So within this DevSecOps 0 to hero repository, where we have the code, along with these files, we can also create .docker ignore file. What is the purpose of it? Very simple. In the Docker file, we are usually using copy dot, right? It's a common practice where we use this command. Now, what does this command do? This command usually copies everything within the folder onto the Docker image. So it copies The app.js, it copies package.json. What if? No? What if it accidentally copies the files like .git? Obviously, you have .git on your machine. What if it copies it? Or what if it copies files like .env? What if it copies node modules? Right? Even why should it copy Docker file? Right? These can only increase the size of your image. You can eliminate that by creating a .docker ignore file. So just create .docker ignore, put it in the repository where you have your source code, and when you run copy dot, what Docker does, it looks at the .docker ignore file and it will ignore copying everything that you add to the .docker ignore file. Very similar to .git ignore concept. When you add .git ignore, Git will look at that file and stop tracking the files that are in .git ignore. Similarly, when you add .docker ignore, when you run the copy command, Docker will ignore copying these files onto the Docker image. That way, you can reduce the image size and copying unwanted files to your Docker image. Perfect. Finally, okay, now that the .docker ignore concept is clear and you know how to build good Docker images, let me tell you one simple concept, how to use your Docker run command. But Abhishek, we know how to use the Docker run command. Now we just use Docker run -p followed by the port, or we just use Docker run -it for taking an interactive terminal within the Docker. That is definitely good, but a best way of using Docker run is by passing parameters to Docker run, something like this. These are parameters that I usually recommend. What are these parameters? Very simple. Let me go through each and every parameter. Read only. Something that I highly recommend. What this does, Docker run read only. That means the process that is running within the container becomes a read only process instead of write process. But Abhishek, what if my process want to write some information to the local host, or what if it wants to write some information to the host system? You can use temporary file system and provide /tmp or any temporary file system, because this will prevent the hackers. If hackers tries to create more volumes, or if hackers tries to create something on the host from the container, this will prevent, because your container is running as a read-only container. And if at all it wants to write something, there is a temporary file system to which it can write. Perfect. Similarly, you can also pass cap drop all and security opt no new privileges. Both of them are used typically to ensure your container does not gain any additional powers. A lot of times, as I told you, hackers, they try to escalate the privileges. When they get access to the container, the first thing that they try is to add more privileges to the container, or they try to see if your container has any elevated permissions, so that they can not only hack the container, but they can also get access to your host system. These two parameters, even if someone like a junior DevOps engineer, someone with a lot of security knowledge, even if they get the containers, using parameters like this in your runtime can highly help you secure your containers. On top of that, PID 100, this is basically to limit the processes. In case someone tries to perform DDoS attack on your container, you can limit the number of processes so that they cannot run more processes on your container. If they run more processes on your container, it will indirectly impact other containers, because they cannot get enough resources like CPU and memory from the host. You can prevent that by limiting number of processes. But Abhishek, what if they try to use a single process and they try to take more resources from the host? What you can do, you can limit your container resources by using hyphen hyphen memory and hyphen hyphen CPU. So using these parameters, you can tell my container should use only these number of parameters. So these are called hardening parameters, or these parameters can help you enhance the security of your container during the runtime. Once again, all the nodes is available in the Day-4 folder. Just go through the README file. I would highly recommend that to you. And also try to practice the commands along with the configuration that I provided in the README file. So go example by example, use the Docker file, run the commands, see the output, then go to the next step. This way, you will never forget the concepts and you can become a better DevSecOps engineer. Thank you so much for watching today's video. If you have any questions, do let me know in the comment section. See you all in the next video. Take care.